Hey everyone, in this video I will look into this pretty popular dataset called Twitter Emotion Analysis coming from these Hugging Face datasets library. And in the immediate next video I will do Distilbert implementation on this dataset. So it will be two series of video, but this one, that is the first one, it is pretty much EDA and data analytics to understand the data. All right, so here I am in my VS Code. Initially, all these imports, all the standard libraries. Only special mention maybe these transformers. That is coming from Hugging Face. Yeah, otherwise all the normal ones. So first, I'm just going to check that my pipeline and emotion detection is working fine. So this particular text I have taken from these another standard data set for Netflix movie reviews from this link. And just a random one I have taken for testing. I need to get a text classification. So this will just tell me the basic emotion, the binary in emotion in this particular text, that is whether positive, negative, and the corresponding score. Let's make a data frame on this. And let's run this cell. Oops, I need to run the entire notebook. So what I used here is just this pipeline module of Hugging Face. It's coming from the transformer package. So this is actually a very versatile and superbly useful module of Hugging Face. This is the easiest way to use a pre-trained model for prediction for any given NLP task. And the pipelines are indeed one of the great way to use a pre-trained model as well. So instead of this text classification, I could pass a model name here. So let's go to their official page indeed. So here I am looking at the Hugging Face transformer pipeline documentation. The pipelines are a great and easy way to use models for inference. These pipelines are objects that abstract most of the complex code from the library, offering a simple API dedicated to several tasks. Yeah, so with pipeline you can do all these things: NER, that is named entity recognition, masked language modeling, sentiment analysis, feature extraction. So in this case I used this syntax to get my text classification. You could pass model, any model like this, that is pipeline, and then you pass the model argument and name of the model. Yeah, so pipeline is super important. All right, now I'm going to what I'm going to do, I'm going to import the dataset module. Of course, I have installed it previously with pip install. List datasets. Yeah. Let's quickly check what kind of things these list datasets have. And then I can quickly print their length of all these data sets and also the first 10 items. Yeah, it's fetching. Okay, so I have look at this. I have 5,385 total number of datasets within these datasets package of Hugging Face. So yeah, it's another superbly useful thing when you are doing NLP projects. Pretty much any standard datasets you can think of in NLP, you will have it in this datasets library. And I'm just printing here the first 10 of them. So here are some of them: acronym identification, AD corpus, version 2, adversarial QA, all these things. Okay, and in this case, for this particular video, I'm going to use the emotion dataset. So I have to first I need to bring in load dataset. This one, my emotions variable will be equal to load dataset and then pass the name of that dataset. That's my emotion dataset. Now let's quickly print it. It may take maybe half a minute to bring it in my local machine. File not found. Let me check it. I think there is an extra S here. Yep. So that was a mistake. So this is my emotion data set, and we can see that now that I ran this, executed this line, that means it pulled in the dataset from the cloud, that is from the server of Hugging Face, to my local cache directory. I'm in Linux systems, so I have these Rohan-Paul cache, then Hugging Face, datasets, emotion. So this is where this dataset will be saved, and the datasets actually is structured like this. We can see a dict format over here, and I have features num rows for my train part. So it has train, validation, and test. So for the train, I have 16,000 samples, for validation 2,000, test 2,000 as well. Let's just define my train dataset. So that will be just emotion, and take the train part. And remember, here dataset is you can treat it like a list, and that's why I'm using this syntax. Okay, that's my train dataset. Now get my label names from this. That would be emotions train dot. You can extract by these key name features and labels. The reason that I'm using labels is because we saw that it features contains this text and labels and their names. Again, I'm getting key error labels. So yeah, again, I'm putting an extra S here. Yeah, so that's the important part. So I have in this data set these 6 categories of labels: so sadness, joy, love, anger, fear, surprise. So these are the 6 emotions in these emotions data set. All right, now I'm going to check the length of the data set again. So I'm just taking a lane of train DS and also a single example. So length of the dataset is 16,000, and a single example from the dataset is like this. It's a dict object. So text, I didn't feel humiliated, label 0. Okay. And the label 0 here, that means because although the label names are like these are the names, but because here I actually printed the names property from this, but 0 here is the index. So each of these 6 has an index associated with it, and that's what it's showing here. Now I'm going to see the column names. You can also do something like this: train ds.column names. And remember, what is our train DS? It is just the train part from the emotions. So if I print these column names, yeah, as expected, text and labels. And the important point to note is here how Hugging Face datasets module represent the data. So we can see here that this single item or single row is represented as a dictionary where the keys correspond to the column names and the values are the tweet and the emotion itself. So this is one tweet, and so this reflects the fact that datasets module of Hugging Face is based on Apache Arrow, which defines a typed columnar format that is more efficient, more memory efficient, than native Python. We can see that the data types are being used under the hood by accessing the features attribute of the dataset object. And if I go to Hugging Face official documentation here in dataset features, it clearly says that features define the internal structure of a dataset. It is used to specify the underlying serialization format. What's more interesting to you though is that features contains high level information about everything from the column names and types to the class label. You can think of features as a backbone of a dataset. Yeah, okay. So in this quick example that they have given, actually pretty nice, from datasets import load dataset. So I have these glue dataset downloaded as my dataset here, and if I do a dot features, I get index label sentence 1 sentence 2. So index here is a value which is of type int32. Label is actually class label, and the value feature tell datasets that the IDX data type is int32, and the sentence 1 and the sentence 2 data types are string. And this will become slightly more clear when we see the data frame of this. So let's do that. Emotions. I take train again. Yeah. So, like I was saying, that under the Apache Arrow data frame configuration, this particular way the datasets module of Hugging Face shows the data that the keys correspond to the column names and the values are the actual tweets and the emotion. Okay, now I also wanted to actually check maybe the first five rows of my train DS data just to see what they contain. So this is my train DS we saw earlier. Train DS, what is train DS? That's I'm just taking the train from the emotion. So let's in this cell, I'm just printing the first 5 elements. Okay, so as expected, so these are my first 5 elements. I have text and I have labels, and the whole thing is a dict. Similarly, if you want to check the first 5 rows of data, the text one, I can do this train ds text, and then I just take the first 5 elements. Let's see what does it print. Okay, so this is only the text part, train ds text, and I have the whole thing output. This whole output is a list, and I have 5 elements in this. That is, each of these 5 element is a string. And now, before I go further, some quick little bit of pre-processing on the data set. So set the format in pandas. That means Now convert all data in the format emotions. Taking everything with the slice notation. And now tell the process. I'm going to use display and df.tell. Okay. And now I am going to write a little method to convert my integer to string. And this method will be required in the for the label column, and we will see why it's required in a short while. Label int to str. Features label, and here I'm going to use int to str. This is predefined method within Hugging Face. So if I go to their documentation, and the day method I want is int to str. Why I'm not getting? Yep. So this is the method that I just use, conversion integer to class name string. Is there any more documentation on this? This is the source. Let's quickly have a look at the source indeed. Conversion integer to class, not is instance, and is not is instance should be okay. It's quite a large method. Now let's see what it actually does. Self dot, okay, this is the, okay, I got it. It just moves the format. Okay, now I am going to need my df create one features called label name. And to that I will apply this method that I just defined, which is label to insteer into Steve. Okay. Sorry, that would be cool. So this is my this was my original data set, that is the before applying the into str, and this is my modified data frame with the new label name as a new column, and this is where I have the actual values of these various label indices. They're not indices, they're just the label number corresponding to each of these actual emotion text. Okay, now I am going to check the class distribution of the label name with a simple frequency distribution plot. So I'm going to need matplotlib here. Matplotlib.py plot splt. Now df value counts. I need the count of these values, and I'm going to keep ascending equal to true. Birth. Now plt dot, let's give frequency distribution classes plt dot show Plot accessor object has no attribute called birth. Yeah, so this is BARH. Okay, so this is my frequency distribution of classes. So we can see joy is the maximum, crossing the 5,000 mark. Surprise is a minimum, almost like 500. Okay, now I am going to use a little bit more beautiful curve, that is the all famous Plotly. Yep, Plotly visualization from the emotion trained data frame. Okay, and for the Plotly, I have already imported Plotly with I think I have imported. Quickly check. PX, where is my PX? Yep, plotly.express as PX. Awesome. So I'm going to create a new column for a new feature of this data set, and I'm going to call it length of the text. This is like a little feature engineering that I'm doing here that I will use much later. And that would be the len of let's do this one first. For I in train text, and what is my I will be I dot split space, single space. Yes, that makes sense. Okay, now figure. First, I'm going to do a histogram, and that will take my train. So PX in a histogram, rows of data frame are grouped together into a rectangular mark to visualize a 1D distribution of an aggregate function, histfunc. For example, the count or the sum of the value y or x if orientation is h. So basically in histogram, rows of data frame are grouped, and the rows that I want to group here is for the column name named this new one that I just defined, which is length of text. And marginal, keep it equal to box. I definitely recommend go check the documentation for significance and meaning of each of these parameters to px.histogram. And then it takes labels, which is dict, that is value, which should be length of the text. Now I'm going to use update traces. These are like a particular attribute of Plotly, and because the graph object in Plotly figure support these update traces, then update labels, things like this. I think that was update layout. And if you really want, I can go and check their documentation. So this is the official documentation, and here if you search for update traces, yeah, so graph object figure support an update traces method that may be used to update multiple nested properties of one or more of a figure's traces. For example, in this example, they are using update traces to update the color of this plot. Yeah, so let's go back to our use case. Traces marker will be another dictionary. So dict line equal to that takes a color, and my color that I decided is this. It also takes a width parameter. I'm keeping it at 2. Okay, now next one is update layout. Title text, which will be distribution of the length GTH of the state, and length of the text by emotion, by emotions. We have 6 emotion, remember? And then yeah, the title X, keep it at 0.5. There was something called font. Yeah, that will be dict size 20. Okay, so and now I'm just going to run this damn cell, and awesome, I got this beautiful plot. So this is the distribution of the length of text by emotion. No, I think I have done a mistake. This should not be same color. The color should be different. Let's see where I did wrong. No, actually, I think I did correct, because here my purpose was just to have the distribution of the length of text by emotion. So I think, yeah, this is what I wanted to achieve. So the mainly, yeah, we can see the length of the data points is distributed between 2 down here up to 46. That's where that's the range it is distributed, and the outlier starts from something like 48 words all the way towards this. So yeah, that's this. Now the next one, I want to do the distribution. So this was by from a plain plotly distribution of the length of text for all the emotions together. That is, in each of these, I have, for each of these bars, vertical bars, I have so many emotions in these. That is, all the 6 emotions are clubbed together and showing in the same color. That is, all the labels are showing in the same color. But now I want to have another plot which will show me different colors for different labels. So let's do that. Is this my markdown cell? Okay. Okay. It will be almost similar. Let's just copy paste, because it will be similar, only one small change. And the changes are, I don't need this line because it has already been defined. I have already created this new column in the previous cell, so delete it. And here in this line is only change. Now in the previous one, I did not mention how the colors will be defined, so the entire bar took the same color. And now I am going to define the color parameter and give it train label. So this is the only addition that I'm making here. So now, according to the label in each vertical bar, the colors will be different. Let's run it. Awesome. So now this is the new plot, and we can see actually these 0, 3, 2, 5, 4, 1, all these are denoting the different emotions like sad, happy, joy, etc., and they are showing in a different color. Now it would have been probably a little bit better if instead of these numbers I had the actual label names. Yeah, of course we can do that, but for now this is all right. I just wanted to see an overall distribution of this. Okay, now I want to also do a plotly graph for the distribution of the labels. Convert it to a markdown cell, distributions of the labels. And this means that uh, all these 0, 1, 2, 3, 4, that is, we have 6 labels, they should be showing in a simple uh, single plot. So my fig histogram, give it the entire train, because now I need the entire data frame. X equal to label, because on the horizontal axis I want to show the numbers of different labels. And the color, color will be equal to label again. That's how the different labels will have different color. Update traces, marker equal to line date. It will be color of what was our previous thing. I think that was also width equal to 2. Update layout, title, text, distribution of labels, title X equal to 0.5, font equal to size 20. Awesome. Now this is the distribution, and the 1 is a maximum number. I think this is what represent the joy emotion, as we saw earlier. But anyway, let's go ahead now. And now I also, so that we built this kind of plot previously without Plotly, but here I wanted to build it with Plotly, because for any graph, whenever you do it in Plotly, it always looks much more beautiful. And this is also interactive. You can actually play around with these configurations over here. Okay, now I want to do another Plotly graph for frequency of the words in trained dataset. Okay, that means in my train dataset, which words are occurring how many times, and that should show me in a overall rectangular shape, and the size of each rectangle inside the big rectangle should be proportional to the number of times each word occurs. So let's do frequency of words equal to trend, and I need to take text. Remember, I think let me check, the original data frame had all the actual tweets and emotion under the text column. Yes, the name of the column is text. All right, and expand equal to true. Stack dot value count. Now I also want to have, if I q, oh, oops, a frequency of, why doesn't it give words top 200, which means frequency of words And by the way, if you are wondering why I used expand equal to true here, it's part of these panda split method. So if I go to their official documentation in pandas, it gives the interpretation here. Expand is a boolean parameter. Expand the split strings into separate columns. If true, return data frame or multi-index expanding dimensionality. So that's the main key point here, that with expand argument you are actually increasing the dimensionality or expanding the dimensionality. And if false, obviously return the series or index containing list of strings. And it actually was explained further in a Stack Overflow question, that the question was string.split with expand equal to true. Can anyone explain what is the meaning? And it gives a very nice examples, that if I use pd.series, this is a regular sentence, and apply split on this string and then do expand true, it actually will be returning by expanding the dimension, because now the string will be split into different dimension, different columns. So 0, 1, 2, 3, 4 will be my new additional expanded columns, and this is the corresponding values. This is a regular sentence for each of this column. And now I am to use this particular thing in Plotly called Treemap, because like I said, the kind of map or plot that I want to build here is something like this. That is, there will be an overall wrapper rectangle, and then each nested rectangle will be proportional to the size of the number of times each of the element appears, and in this case the elements are the number of words. So they, let's see what they do, what they are saying. Treemap charts visualize hierarchical data using nested rectangles, and that's what I want. But I want the variety in here, tree map of a rectangular data frame with plotly.express, because I'm using plotly.express, and it says hierarchical data are often stored as rectangular data frame with different columns corresponding to different labels of the hierarchy. px.treemap can take a path parameter, okay, corresponding to a list of columns. Note that id and parent should not be provided if path is given. Okay, so let's see this example. Px.treemap, it first parameter is df, then it takes a path parameter which is px.constants, all daytime sex values are total bills. Okay, so this is the various column names, and this is the nested rectangle. Where is our data? Okay, just okay, for I kind of understood how it should be built. I think you got the idea that this path parameter will take the column names, and values will obviously take the, in this case it takes total bill. Okay, so let's go back. So in this case, let's to have the column, to have the values of the words, let's print this frequency word top 200, and we get this kind of structure. So here this looks like a dict format, and I have a key and a value, and I, feel, and to, all these are the keys, so I can get hold of them with index. Let's see. Yes, if I do frequency of top words dot index, I get the actual values of these words. Okay, I kind of getting it. Now let's do next. layout, my title text will be title. Font is again date, and size traces, text, label plus value. Awesome. That's exactly what this is about. So we can see this is the distribution of the number of counts of the various words in our data set. And obviously, this is the highest number of counts, 25,859 number of times. And also we can see all these and to the a of these occurs too many times, and obviously that's expected because this data was not cleaned, was not, the stop words was not removed, it was not, the lemmatization was not done. So now let's do some text pre-processing. First quickly check our original data frame as it is. Yeah, we have text, label, length of text. Okay. Now I will be using NLTK library for doing the tokenization, and we have already imported the important method from NLTK, which is word tokenize. So let's define a quick method. But first of all, to use to tokenize with NLTK, I first had to run this particular line, nltk.download all, and what this will do is it will create a directory in my home folder in my machine called nltk data, and bring in almost like 3.8 GB or 3.9 GB of corpus data from nltk, because that will be required for my text tokenization. And don't worry, this huge 3.8 GB of data will not be loaded into your RAM each time you run your word tokenization. I have a separate video indeed to check and verify that the whole 3.8 GB of downloaded corpus data from NLTK was not loaded into my RAM during the runtime. And this thing you have to do only once, because once it's there in your machine, then it will be remembered always by NLTK. So you don't have to run it 2 times. Yeah. So now from I think I did not import these word tokenize earlier. Let's quickly check. Did I import word tokenize? Yeah, looks like nltk.tokenize import word tokenize. Yes, I have imported indeed. So that's fine. Now defining the method for tokenization. Yeah. Now let's tokenize. I'm going to create a new column name called text tokenized. Okay, let's actually run it. Awesome. We can see this new column that has been tokenized. Okay. Now what I am going to do is a stop word removal. Yeah. So for that also, I'm going to use NLTK's particular module called stop words. I think I have imported it already. And there it is. We have already imported nltk.corpus import stop words. And after stop words, I also need to do lemmatization. And for that, I have imported this word net lemmatizer. Okay. I'm going to use set, and within set, stop words English. That's what I need. Stop words remove. Stop words removed. Yeah. Return. What I need to return is a list where item for item in inputs if item not in stop words. Yep, that should do. And now I'm going to apply it. So train text after, I'm creating a new column, train text after removing stop words. This is the column that I'm going to apply my stop words removal on, and that column will be text tokenized. Dot apply stop words remove, and check my train. After that, I'm getting a key error. Train tokenized. Yep, this is not train tokenized. This is text. Let me check another time. Text tokenized. Yes. All these silly mistakes. Stop. I'm just adding the stop words into my VS Code's permanent spell checking configuration. Otherwise, it keeps giving me, it says misspelling. Okay. Anyway, so now it should run well. Let's run it again. Awesome. So this is my new column, and from this, all these stop words has been removed, like all these I, off, etc., etc. And the last thing I need to do for my preprocessing here is the lemmatization. So lemmatization is a process of grouping together the different inflected forms of words so they can be analyzed as a single item. Lemmatization is similar to stemming, but it brings context to the words. So it links words with similar meaning to one another. So it's like a semantic meaning kind of thing. All right, now lemmatizer. I have to create an object from the WordNet Lemmatizer module. Lemmatizer. Again, I have to, why this is again Lemmatizr. What is there anything? Okay, let me just keep it as it is for now. We'll check it later. So define a method which will lemmatize my text after removing stop words. So this is the column that I want to lemmatize. Lemmatization, and it will take inputs, return lemmatizer dot lemmatize lemmatizer dot lemmatize, and that would take my word, and this word will be let's complete for x in inputs, and word will be equal to x position v. Okay, and then apply this text ATIZD to train. Let me just copy from here. It's a long text. From ATIZD to when lemmatization. Okay, that should work. All right, now that's my new column, very right, extreme right, text lemmatize, and the things that you see now didn't feel. All these are lemmatized form of the original this data set. So this whole function was applied on this column, and this is the output column, which is a new column after applying the lemmatization through these lemmatizer.lemmatize. Okay, now another step I have to do. Only last two small steps are remaining, maybe another 5 to 7 minutes, that's all. Joining tokens into a sentence. And what do I want to join? I want to join the text lemmatized this column with a delimiter of a single space. So let me see. Joining tokens into sentence. Text cleaned. This is the final form of the clean text. Train text lemm. Was this the same? Text underscore lemmatized lemmati. I always make a mistake in this spelling. .str join by a single space. Yep, didn't feel humiliate, didn't feel. Yeah, so now you can see this this list now has become a single text, and we have joined them with this delimiter of single space. All right, now the very last step, I need to build a word cloud, and for that we already have imported the word cloud module. Have I? Yes, I have. Word cloud, import word cloud. You cannot leave any NLP text analytics project without doing a word cloud. Let's keep max words at 150. Random, it takes width, height, margin. Where is that random state thing? Anyway, it takes a random or a random state argument, and keep it 30. Co-location CADIONS equal to true, and dot generate, that would be str, and I need to pass the text cleaned, so train and text. Okay, now awesome, that's my word cloud. Yeah, so field, that's a most prominent word in this word cloud. Okay, now now that we build and see that in here we cannot see any of those stop words, obviously, because they have all been removed, then lemmatized, all these things has been done. So previously when we did the tree map with Plotly, we saw that I came with the highest number of times, and now I'm going to do this plot again just to check the difference. Okay, let's go. Let's do that plot again. I can just copy paste the code from there. Right? Yes. So I copied the thing. Now I'm just going to paste it here. Frequency of words. Now instead of text, I need to take this one that has been cleaned, which is text cleaned. And now run this. Awesome. And as expected, now there is none of those stop words, and instead we see that feel occurs the most number of times, and which is what we saw in the word cloud as well. That is, feel is the most prominent one. All right, that pretty much wraps up this video. If you have liked this one, smash the like button, and also do subscribe, because I'm going to do many interesting NLP projects over the coming days and weeks. So see you in the next one. Thank you very much for watching.